Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, a grand welcome to the new course on SwayamPrabha offered by Department of Maritime Engineering at IIT Gandhinagar. Maritime Engineering is a new program launched at IIT Gandhinagar under the support of industrial partners and academia partners in India as well as in abroad. This is a skill developed, professionally tailor-made program, and the courses which are taught in this program will enable the job prospects in maritime industry in the coming years in a very strong manner. IIT Gandhinagar is leading in India in this program by shaping the maritime engineering industry as well as academia in a novel manner such that all pocket holes which are going to add strength, support, decision making, research and development, maintenance and capacity building of different frontiers of maritime engineering are touched upon in the courses and the programs offered in the Department of Maritime Engineering at IIT Gandhinagar. You have master's program by thesis and by research MTech you also have PhD program where expert faculty in India and abroad are available for you to guide and also to track you on a correct path of advanced research in the frontiers of maritime engineering. Friends, under this, to enable the capacity building for practicing engineers who will also gain knowledge and also develop inclination of higher interest in learning in maritime engineering, a course offered Maritime Structures Under Fire, Blast and Explosion is now launched for you. So, I am Professor Srinivasan Chandrasekaran, heading the Department of Maritime Engineering, and along with me Professor Gaurav Srivastav, heading Department of Civil Engineering, will be coordinating with me in offering the contents of this course for you. So, friends, welcome to the first lecture on this course, where we talk about introduction about maritime structures under fire, blast and explosion. So, welcome friends, it is a very interesting course and I hope you will enjoy the contents of this course by also reinforce your learning going through the additional reference materials listed in this course in SwayamPrabha website. As well as, friends, do you have any questions about the contents or any problem solving, or do you need any assistance in terms of industrial problems or research applications, etc., you are free to approach the Department of Maritime Engineering, IIT Gandhinagar, and we are always open to discuss with you the problems, academia, industry, capacity building, research fronts related to maritime engineering. We will extend our best support in collaboration with the institutions and academic partners in India and around the world who are committed to work along with jointly with IIT Gandhinagar in making this program successful. So, let us come to the first lecture, Introduction on Maritime Structures Under Fire, Blast and Explosion. Let us first understand the objectives of this specific course. This course will make the participants familiarize with the design principles of maritime structures under the special loads. The design of maritime structures under conventional loads such as environmental loads arising from winds, wave, current, impact are already covered in another course offered at SwayamPrabha. I would urge the participants to also register for that course and learn more information about that course. In this course, friends, we will talk about the design methodologies, but exclusively to special loads such as fire, blast and explosion only. So, it is a high end specialized course which is very useful, and I am sure that you will not have any parallel course touching upon such broadly widened contents on maritime engineering and maritime structures. So, please do register for this course and enjoy the maximum benefit through the best academicians and the best practice of industries being participated contents in this course. This course will deal with the basics and application examples of maritime structures under these special loads with using Indian and international design codes. Upon successful completion of this course, the participants should gain extensive knowledge about the design approaches of maritime structures under the special loads such as fire, explosion and blast loads. It is relatively new course, friends, with intensive content presented towards structural design of maritime structures under these special loads. It is very useful for masters, PhD and postdoctoral students and also for practicing engineers in this sector. The course contents are framed purely on job perspective in maritime industry, meeting Indian and international standards. This course is open to students and professionals of various disciplines such as civil, structural, mechanical, coastal, port and harbour, naval architecture, safety and petroleum engineering. You can see a wide discipline of list of courses are open whom can register for this course and draw the best benefit from the contents of this course. So, welcome to this course, friends. The objectives are preset in the first lecture itself, that you know what you are going to learn. You know how much extent you will learn in the next slide, where we will discuss about the course outline. This course has the following outlines. First, we will talk about the maritime structures, the type and classification, and materials for construction. This is necessary, though there are other parallel courses available in Swayam and SwayamPrabha, which is talking about ocean and offshore engineering structures and courses related to them. However, for the best fit of knowledge and explaining them the basic fundamentals in terms of maritime engineering approach, we are having introduction to the maritime structures, which will talk about the types and classification of the structures and the structural action and the materials for construction of these kinds of structures. Once we understand them, we will take you forward to learn accidental loads in terms of fire, blast and explosion. So, we will make a complete numerical modeling and of course, the analytical models as well to explain the fire engineering and fire chemistry, blast and explosion from the first principles. We will talk about fire chemistry, classification of fire, types of fire, suppression systems, extinguishers and firefighting systems which are useful for maritime industry. Then we will talk about explosion chemistry, where we will deal with types of explosions, computing damage caused by explosions, numeric examples, MATLAB programs and industrial explosions as an overview. We will also talk about the control and mitigation processes leading to safety perspectives using flammability diagrams as one of the best suit to attempt to mitigate or control fire occurrences in industrial structures. When we talk about fire loads, we will explain how fire loads are computed on structures, and then we will also discuss about fire limit state design. We will use international code guidance to discuss the design philosophy and also discuss the classification of these design procedures based on international codes and National Building Code of Government of India. We will also extend to make you understand the fire safety guidelines, where we will discuss about the planning guidelines for fire safety, which can be very useful for huge and heavy industrial structures like offshore platforms, processing platforms, regasification platforms and also ONGC platforms. Problems on fire resistance will be solved using Indian and international codes of practice. We will also discuss about a detailed numerical modeling of blast loads, estimate of blast loads, design of structures under blast loads. We will also discuss a few case studies of accidental loads which has occurred on structures, and we will derive learning lessons from these case studies, and then we will end up in designing the layout for firefighting systems which can help mitigate or protect these structures and the fire would have not occurred during that particular layout which has been existing in these structures. So, during these examples, what we are discussing will touch upon various international and national case studies, problems, examples, literature review and research papers which are all listed in this references of this course. So, I would request the audiences to go through them in detail, have a copy of them with you and try to learn them thoroughly as you go parallel with me in learning this course. So, friends, these are the references which are cited, which will also be available in the website of this particular course in SwayamPrabha. You will see that most of the capacity building of this particular course comes from the course coordinators. So, we have books on computer design, fundamentals of offshore engineering, fire resistant design with me and Gaurav, design aids for offshore platforms under special loads by me and other international authors, offshore compliant platforms, analysis and design, offshore semi-submersible platforms, analysis and design, structural health monitoring, advanced steel design of structures, advanced structural analysis using MATLAB, dynamic analysis and design, design aids for structures under fire loads, myself and Gaurav, health, safety, environmental management, myself, offshore structural engineering reliability and risk assessment, ocean structures, construction material and operations, Advanced Marine Structures, Dynamic Lands and Design First Edition, Advanced Theory of Offshore Plant Feed Engineering, ASCE, Design for Blast Test and Buildings in Petrochemical Facilities, etc. So, friends, list of references covering upon a wide range of topics in detail with MATLAB programs, applied case studies and examples are available and listed to you. The details of this are also listed in the website of this particular course at SwayamPrabha. I request that if you belong to an education institution and if you take this course as an elective or a core course as a faculty or as a student, please request your library to possess the copies of these reference materials, because as a collective approach and help, this will reinforce a very interesting and sound capacity building within the university. Please possess the copies of these codes and the books which has been listed in this website to a copy to a library, and if possible also try to own a personal copy of yourself, so that you can use this as a permanent reference for you in future as we go ahead. Most of the examples and the MATLAB codes will be taken and drawn from these references. So, if you have them in advance, you can always learn a step ahead of what we are discussing in the course. So, friends, let us talk about maritime structures to learn about. So, for people to learn what is a maritime structure without leaning forward to other courses and other textbooks to know more about them, let us discuss very briefly in this lecture what we intend to discuss about or describe about maritime structures. Maritime structures essentially are of multidisciplinary interest. It attracts people and professionals from civil, structural, mechanical, electrical, electronic, safety, materials, ocean, offshore engineering and naval architecture, almost all wide disciplines of engineering which is being taught in leading schools of engineering in the country as well as in abroad. It is a multidisciplinary sector of interest. Maritime structures are those special kinds of structures deployed for various functions. A few of them are coastal protection, naval defense, oil and gas exploration and production, ship docking and maritime transport. If you look at the green corridor and the blue economy and corridor which is proposed by the government in the future prospects of maritime industrial growth in the country as well as international policies globally in the world, you will see that the maritime transport sector and the ship building and docking is picking up very rapidly all over the world as well as in India being a peninsular country, which will now demand lot of job prospects for maritime engineers in the coming future. So, maritime structures are those kind of special structures which are deployed to perform various functions. So, once I say they are special structures, there are various structural systems which are deployed. As you know, when these structures are deployed offshore, that is away from the coast towards the sea, the water depth in sea at different locations keep on varying. Therefore, these structures are classified based upon the depth of commissioning as shallow water, medium, deep and ultra deep water structures. So, these structures are also grouped based upon the water depth at which these structures are commissioned. In addition to them, there are structures also constructed along the coastline as port and harbours, coastal structures and jetties, which are also part of maritime structures, which will also deal in detail. As we also know, and very interestingly to learn about, these structural systems, since deployed at various sectors of water depth and various geographic locations, the geometric design of these structures and configuration are very special. So, let us put a point here. The geometric design or let us say the structural design or let us say the structural form of these structures are very special. Okay. Though they have a very common material for construction, say they are steel and concrete, common materials. There are other materials also being used. But the geometric form of each structure is different. They are designed to counteract the loads by two ways. One, by the structural action which is coming from its strength. Second, the structural action which comes from its geometry. So friends, we intend to say this specific idea as form dominant design. It is not new in structural engineering. I can give many examples of form dominant design. One simple example is an arch. We know when the beams are spanned between 2 points, under any given loading, the beam will deflect. To avoid this deflection, if we constructed an arch, whatever may be the loading applied onto the system, the arch has to first become horizontal, then it has to bend. So, it is understood from the intuitive perspective that arch possess extra reserve energy or reserve strength which is coming from its geometric form. So, that is one classical example of form dominant design. The second one could be domes. You must have seen geodetic domes which are constructed to cover large span of structures. Large span. The span will be about, let us say, 20 to 25 meters in diameter. So, they construct domes. So, the supports are only along the periphery, and you could have seen that most of the ancient Roman structures are domes. You could also see most of the temple architecture in India, most of the Mughal architecture in India are also comprising of domes. So, domes are constructed because over a thin layer and membrane of material and structural element, this can withstand huge amount of loads, gravity and lateral. This is another classical example of form dominant design which is very helpful. So, form dominant in structural design is not a new aspect. This has been practiced in over centuries in many parts of the world. But when it comes to maritime engineering or maritime structures, they have been very challenging and they have been very, very useful, and they are successful in alleviating the environmental loads acting on them. So, form dominant design is one aspect of maritime structures design where the resistance of the structure developed by the structure apart from the material strength also comes from the geometric form of the structure. So, if you talk about large floating structures, they all form under this category. So, therefore, friends, depending upon the depth where they are commissioned, like shallow, medium, deep and ultra deep waters, which are specified and classified based upon the water depth and wave height, wavelength ratio, etc., which are hydrodynamic parameters of environmental loads coming onto the structure, they have a different geometric configurations to withstand the loads acting on them. So, it is rather fascinating for us to know that the structural systems deployed at different water depths are unique, they are not similar. Okay? Under environmental loads, their structural actions vary widely due to their compliancy. Now, the question comes, what is compliancy? So, to explain this, let us talk about what is compliant. Compliant refers to flexible. Now, you have got two types of structures which are generally constructed and designed. One is very strong, which is very stiff and has rigid actions. Other is also strong but flexible. Okay. So, when you talk about rigid structures, they have a very strong foundation. Okay, they have a very strong foundation. It can be even pile foundations, it can be raft foundation, and so on. Okay. So, they have a very firm, strong foundation which can transfer the load from the superstructure to the substructure. Okay. The load path is very clear. But on the other hand, when you have structures which are floating, let us say this is my water level, my seabed, my depth of water small d. Okay, this is my seabed. This is called mean sea level. So, the system is completely floating. As we know by Archimedes principle, any body which is floating will always tend to attract buoyancy forces acting in the upward direction. We call this as buoyancy force, which will act upward direction, which is proportional to the displaced volume of the body in water. Okay. So, you imagine that I have a box which is hollow inside, okay, which is hollow inside. Okay, it's hollow inside. But the body or the box is very large in size, L, B and let us say this is H, but I call this immersion as H dash. So, L and B are very large, let us say, but it is hollow. So, since it is hollow, the weight is very less. Okay. But since L and B are very large, the buoyancy force is very high. Correct? So, what happens is when the buoyancy force exceeds the weight, the system becomes positive buoyant. So, it can easily float, right. When the buoyancy equals weight, it becomes neutral equilibrium. Of course, when the weight exceeds the buoyancy, the body will sink, which we do not want. So, we are now thinking about a structural system which is highly flexible, which is completely floating, where the principle of buoyancy helps me to support the loads acting on the system. So, the buoyancy exceeds the weight because large volume is displaced, but weight is very less because system is hollow inside. Okay. So, therefore, large buoyancy helps the structure to receive the loads acting on it. So, positive buoyant structures which are flexible in nature will also help the structures to alleviate the loads acting on the structure from the environmental features such as wave, wind, etc. So, they become very flexible as they keep on floating, they keep on moving. So, they become very flexible. The moment they become flexible, then we talk about their motion characteristics or displacement characteristics. To understand the displacement characteristics, let us introduce something called degree of freedom. Degree of freedom is independent displacement coordinates help to represent the inertia content present in the system. So, once you say displacement, I can have two types of displacements. Okay. One is translational, other is rotational. In terms of analysis, these are called kinematic degrees in terms of analysis. Okay. Now, they have sign convention. Let us see what is the sign convention we use. Let us have a point in space. If the point or the body mass is free to move along x axis, free to move along y axis and free to move along z axis. So, we have three translations. Okay. If the point mass is free to rotate about x axis, rotate about y axis, rotate about z axis, we call three rotations. So, displacement along x, along y, along z have a special name. This is called as surge, this is sway, this is heave. Similarly, rotations about x, about y and about z have a special name. About x is called roll, about y is called pitch and about z is called yaw. So, a point mass in space has 6 degrees of freedom, okay? Namely surge, sway, heave, roll, pitch and yaw. Okay. At any given point of time, you will notice that if you take a two-dimensional plane visibility of this problem, let us say we will imagine a plane of x y. Okay. So, let us see what are the degrees of freedom active on this plane. So, on the plane x y, the degrees of freedom active will be motion along x, so we can say surge, motion along y we can say sway, okay. And what else can you see on the plane x y? Rotation about z axis, that can also be seen on the plane. So, one can say rotation about z axis is yaw motion. Similarly, if you can associate any plane, zy plane, then xz plane, you will see at least 3 degrees of freedom will be active. So, comprising all the 6 distributed in a different form in different planes, these are all the flexible degrees of freedom a body mass can move in space, and flexible structures or compliant structures essentially has 6 degrees of freedom in space. Okay. So, when we do analysis and design of these, we must take care of that these degrees of freedom are computed and then they are manipulated in such a manner that the design satisfies their compliant requirements in accordance with the international codes of practice. Okay. Having said this, let us now talk about different types of offshore structures. Offshore structures are subset of maritime structures. Offshore structures are essentially used for oil and gas exploration. So, we will talk about these kind of structures. Okay. So, there is a variety of this classification happens depending upon the water depth where they are commissioned. Let us say if this is my mean sea level, which I am showing here, okay, mean sea level. The water depth is not uniform parallel to the mean sea level. You will notice that the water depth keeps on changing, is it not? The seabed profile is irregular and random. So, the depth of water keeps on changing at different locations, am I right? Depending upon the depth of water which is available at different locations, the type of structure which are commissioned these locations also vary. the geometric form, the type of construction, the type of materials being used, and the structural design and the member alignments all vary depending upon the geometric form which is being assumed by the structure at different water depths. So, primarily water depth at which they are commissioned decides that classification and type of the offshore structure. So, starting from this understanding, let us first look at fixed jacket platforms. Fixed jacket platforms essentially are rigid based bottom supported structures where the superstructure load acting on the structure from the gravity weight, from the wind load, from the wave load, all will get dispersed to the foundation of the seabed using piles. So, jacket structures are examples of structures where they are rigidly fixed to the seabed. So, we can write it here. These structures are rigidly fixed to the seabed. So, in the literature they are called as bottom supported structures. Okay. So, the name jacket is given because look at the configuration of this. It is essentially a steel member, series of members which are interconnected using braces. Okay. This structure remains transparent to the passage of waves. So, it is called as a jacket. It is also called as template structure. Okay. The main advantage of the structure is since it remains transparent to the passage of waves and wind, the structure does not receive much load from the environmental loads. However, unfortunately, this structure receives lot of load from the deck or the top side because of operational machineries, equipments, living quarters, cranes, dead weight and payload acting on the deck of the structure. So, the structure is subject to huge self weight and applied loads on the deck, comparatively lesser on the wind and wave, lesser in sense because they are transparent to the wind and wave. The moment you make any system transparent to passage of the loads, the members will not attract the loads, therefore, the members cannot be and need not be designed for such heavy combination of these forces. Okay. So, the bottom supported structures are rigid, firmly fixed and they tend to attract more forces because they are bottom supported. Okay. And amongst all the classification of structures done so far, these are the structures which are intended to be designed for shallow water depths, water depth up to about 300 meters. Okay. I am writing it here, approximately a water depth of, write it here, approximately a water depth of 300 meters up to 300 meters. Okay. The second type of structure which is also a fixed type structure is a gravity based platform. We will talk about that in the next slide, but this slide shows you different types of structures commissioned different water depths. Okay. Complaint towers are structures where the area of cross section of the tower is much lesser compared to this. So, since it is much lesser, it enables the tower to be installed at a greater water depth compared to this. Okay. These are called guide towers, provided we connect a guy to connect them to the seabed. These are called guy wires. Okay. The other type what you see in the screen is a tension-like platform where the bottom supporting structure of a truss is completely removed from here and the whole structure is floating, but position restrained using something called tethers. Tethers are nothing but cables or wire ropes. But friends, interestingly, these cables are of diameter 50 to 100 mm, solid steel. So, they cannot be called actually as wires, but they are called as tethers or sometimes tendons. Okay. So, now these legs will be under axial tension. We will talk about the design parameter of this slightly later, but these axial tension will try to pull the platform down, because by design buoyancy of this platform exceeds the weight of the platform. Therefore, the difference in buoyancy and weight will be balanced by additional forces in the tethers, which we call as T naught. Therefore, if you want to write equation of balance equilibrium, static equilibrium for this, Fb acting downward plus T acting downward, Fb acting downward, T plus W acting downward should be compromised by Fb acting upward. Okay. Fb will act upward, W will act downward, T also will act downward. So, the difference between the buoyancy and the weight is compromised by the axial tension in the tethers. So, these are called positive buoyant systems, where buoyancy exceeds the weight by design. So, they are floating. Okay. This is another example of a mini TLP constructed in Gulf of Mexico. This is a fixed jacket platform, the compliant tower, floating production systems. It is completely floating. It is a production unit which is used for oil and gas production, tensioner platform and single point anchor reservoir, which is power platform. So, these are some of the example structures which are constructed different water depths, at different locations in different parts of the world. They are all subset of offshore structures, and they also become a subset of maritime structures. So, maritime structures have different structural form, different geometry. The substructure and superstructure significantly varies between the platforms, because they are governed by the water depth where they are commissioned, and usually and most commonly steel is used as structural construction material for these kinds of platforms. You can also see the top side, which is highly complicated, of any offshore structure. This is called as a flare boom, the drilling derrick, this is a crane, these are drilling derricks, these are electromechanical equipments, helipad, living quarters, different tier of decks, and then the substructure. The one which goes below water is called the substructure, the one above water is the superstructure, the one here is called as a deck. Okay. You will see that the structural form of the substructure, mostly they are different, but superstructure mostly they are same. So, there is no much variation in the superstructure of these structural systems. The variation comes essentially from the substructural part of these structural systems, because as the water keeps on increasing of commissioning, the fact remains that the structure in the subsystem should be enabled to encounter these loads without much interference of these loads and reduction of weight. So, type of offshore structures now can be classified as 3: bottom supported, compliant, floating, and of course, the fourth one added to this is new generation platforms, which is a very recent addition to these types of offshore structures. Okay. Under the fixed type, which are essentially bottom supported structures, we have jacket platforms which are called as template structures. We have gravity based platforms which are called GBS. We also have something called jack up rigs. which are all comprising to this subset of type of offshore structures. Look at the complaint platforms. We have guide towers, articulated towers and tension platforms, which comprise to this subset of types of offshore structures, and they all belong to maritime structures. The floating type of platforms include drill ships, semi-submersibles, FPSO, floating, production, storage and offloading systems, and spar, single point anchor reservoirs. These are all belong to floating platforms, and the new generation platforms which are not yet commissioned, but which are in advanced research stage in maritime sector are triceratops, buoyant leg structures, regasification platforms and so on. So, friends, as a whole, offshore structures are classified into 4. Okay. The substructural design of all of them are different. The superstructure has more commonness amongst them. Okay. So, if you look at a history how they have been constructed, we will talk about that slightly later, but still for your information we can say that the jacket and GBS platforms were constructed in 1907 onwards till about 1940 rigorously. Of course, we have in India platforms constructed 1980s as well, but after that these type of structures are not found to be comfortable for oil and gas exploration, because there is no oil and gas available at shallow depths anymore. So, these structures are not suitable for deeper water depths. So, they are generally commissioned at water depth up to 300 meters. Complaint platforms are the most successful platforms in this group, where TLPs are most commonly commissioned in the Gulf of Mexico and US, as well as a few of them in Australia, UK, etc. India does not have a TLP, but we have these platforms which are commonly seen around the world. They are one of the most successful designs in complaint platforms. They have been constructed in place from, let us say, 1960 onwards, and still the construction is going on. They are constructed in water depth varying from 200 meters to even as deep as 1000 meters. Okay. Floating platforms like drill ships, semi-submersibles, etc. can operate on any water depth, because they do not need a substructure and foundation system. Okay. So, they can operate in any water depth varying from 250 meters till 1500 meter water depth, and they have been in use very commonly since 1980s, and it is continuously in use now. Triceratops are new generation platforms designed to operate water depth exceeding 1500 meters. Okay. Nothing is constructed so far, no platform exists, but it is an advanced design or advanced research stage. So, offshore platforms are grouped in 4 as you see on the screen. Okay. You will see that the structural forms and types vary essentially with water depth. They have become obsolete as you grow new, and these platforms have become more fortunate and very useful and very innovative compared to these platforms. Okay. Out of this, you will now notice that floating type platforms are most commonly being used because of 2 reasons. One, the substructure involvement of cost is practically 0, and the superstructure, though it is expensive, it can be moved from one to other location. Therefore, since because mobility and versatility, these platforms are very highly preferred by international industrialists. Let us briefly look at all these classified platforms very briefly, so that we also understand the structural action, the platform composition, the geometry, etc., before we move forward to understand the design under special loads like fire, blast and explosion. Fixed platforms are most primitive platforms where the bottom of the platform is fixed to the seabed. Because of this, they are relatively very stiff and they are insensitive to lateral loads. They resist the load by strength. Okay. Designers are convinced that such structures are well suitable for oil and gas exploration due to the insignificant response to the lateral loads. The construction methods are also supportive as they are mostly installed in shallow water depths. Fixed type platforms are not preferred for higher water depths because of two reasons. As you go deeper and deeper, the substructure cost phenomenally increases. Secondly, the construction, installation, commissioning becomes very difficult and complex at deeper water depths. Therefore, these platforms are restricted to only shallow waters. There are some salient points about this platform which we want to highlight here. Fixed platforms tend to attract more forces because they are very stiff. The members have larger cross sectional diameters and dimensions. Thickness are also more. They are required to sustain these loads because the design is essentially based on their strength. So, the large diameter members, thicker members are used for construction in these platforms. The construction becomes expensive because the colossal weight, the self weight of the platform is very heavy. I can give an approximate example. The self weight of a typical jacket structure will vary anywhere from 60,000 tons to about 85,000 tons. They have a very higher downtime for commissioning. A typical period to construct a jacket platform will take about 3 to 5 years. Huge downtime for commissioning, and though steel can be reused, but most of the steel underwater gets corroded. Okay? So, reusability of the platform becomes a big question, and decommissioning also becomes a big trouble, because the platforms are founded on seabed. You got to unfound them, you got to remove them from the seabed, and that is a big challenge. So, some of the salient points which are merits and demerits of this platform are discussed here. The second type what we saw in the list is the compliant type platform. Compliancy refers to flexibility. Flexibility means movement. You allow the movement of the platform. Therefore, they cannot be permanently fixed to the seabed, but they need to be anchored to the seabed. If you do not anchor them to the seabed, the platform will have complete motion continuously, and the platform cannot be used to explore oil and gas or produce oil and gas, because the platform needs to be stay in position if you want to explore oil and gas. Compliancy refers to flexibility. Flexibility in terms we talk about movement. Hence, it refers to those kind of structures which have capability to move along the external forces, and this relative motion will make the platform to receive less loads compared to the fixed ones. As the structure becomes flexible, it responds to external forces not purely by its strength, but it also undergoes large displacements as well. Okay? This large displacements only will actually make the platform to receive lesser loads compared to other ones. The method by which they are constructed in seafloor are different significantly compared to the fixed platforms. Compliant platforms are used for drilling, especially in deep sea. They are connected to the seafloor by cables or tethers, so that these platforms can keep on freely moving within their upper and lower limits of displacements, and this motion helps them to counteract the loads acting on them. These structures therefore strongly rely on restoring buoyancy forces, okay, to stay in equilibrium and sustain equilibrium and stability under the encountered unilateral loads. These structures avoid resonance by operating a frequency which is far different from wave and wind, therefore, they do not produce excessive displacements under the wave and wind action. Some of the salient features what you see as large displacement, compliancy, which is flexibility, the dependence on restoring buoyancy, encountering load by large displacement are some of the salient features of the design which makes this design as one of the greatest advantage design in structural engineering or in maritime engineering. These are very special kinds of platform, friends, which are most successfully deployed in deep waters for oil and gas exploration. Floating production, storage and offloading is another set of platform which we will discuss in the coming lectures. So, we will talk about now the summary. So, friends, in this lecture being introductory lecture to the course on maritime structures and the special loads such as fire, blast and explosion, we talked about the type of maritime structures, their functions very briefly. We also talked about classification of offshore structures, very briefly talked about the structural action, we discussed about the fixed type, the compliant type of offshore structures in detail, and we learned that the structural form heavily dependent on the depth of water where they are commissioned, and we also learnt about something called form dominant design, which is one of the most successful method of design in offshore compliant platforms which are useful maritime structure. Hope you have followed the lecture and you will stay with us for the remaining part of these lectures in this course. Thank you very much. Namaste.